Good, good. Thank you. So thank you very much. So I will today present you quantum machine learning for change detection using satellite imagery. So just like to kind of, say what is a change detection. So change detection usually kind of identifies differences between, in the satellite images between the same location taken at the different times. So it can be treated as segmentation problem. And we can kind of see, what has changed and what has not changed between these two time slots. So, why we wanted to try with I wanted to try with quantum machine learning is usually the satellite images, they can be big and they can have a multiple spectral data. I also thought that once we kind of start using radar images as well, that, kind of getting the wave nature of radar images can also kind of help if you use quantum machine learning models. So these are just like some of the reasons why. What are the applications? So I mean, change detections can be used for detecting when some big disaster events happened, like flooding, like wildfires or earthquakes. They can also be used for urban planning to see if there is like some illegal construction happening somewhere. If there's some environmental changes, such as like deforestation or like coastal erosion, and a lot of different applications can be used for this, and it's something that we closely kind of do at work as well. And especially in the case of disaster response, we want to know, okay, who are the people that are affected, what is the infrastructure that are affected, and then like we can kind of like with the satellite images without going on a different part of the world, kind of figure out where maybe we need to kind of send the resources and allocate some resources as well. So when it comes to the satellite sources, they're like Sentinel-2, Sentinel data that are from European Space Agency, Landsat, MODIS from NASA, and there are also commercial ones, Planet and Maxar, which have the best resolution and of course are the best for doing this kind of detections. But the thing is, like these can be very computationally heavy. So that is also one of the reasons why we want to try, with the quantum machine learning. So, the quantum machine learning approach that I took for this project is the quantum annealing using the QSEG approach and QSEG algorithm from the paper. So we are trying to formulate the change detection as like a image segmentation problem using the converting the image Earth observational image into a graph, and then like solving this as a QUBO problem as well. So this is just like a sketch of how this works. We have Earth observational image. We convert it to the QUBO problem, and then like this is sent to the quantum annealer in order to embed this QUBO problem, and then using the I don't know if you can. And then using the quantum annealer and with the quantum tunneling, we can actually, find the global minimas and then like partition this graph into different segments. So you can kind of see here that from this graph partitioned, we get like two classes in this case, and then we can easily kind of get the segmentation mask. So the data that I use, this is just like one kind of part of the satellite image because it was quite big, and this was the image from the Pakistan flood that happened in 2020, where pretty much like a third of the country was heavily impacted. So we can see here, like there is like a buildup area, and we can also see this like green and like dark green. Those are all flooded areas as well. Since I did not have like the ground truth segmentation mask, I converted the original image to the red, green, blue, and from there there is a method where like you can kind of use these different bands in order to calculate kind of like a normalized difference water index to kind of, you know, detect where the water is. And this kind of yellow purple mask is like something that pretty much looks like, you know, where the flooding happened. So this is just like for me to kind of be able to you know, kind of understand, you know, if my segmentation results are like meaningful or not. So again, as I mentioned, I went like from the image to the graph. And here, I mean, because like, I don't know, like I could not really see properly, I tried to kind of like color saturate this graph to see better these edges and these two different classes. So you can hopefully see as well, you know, as I'm sharing. And then the graph that I constructed, it was using the recommendation from the paper, using the Gaussian distance with sigma equal 0.2 for the flood detection. So in this article, they also like used flood detection as one of the change detection problems. And I used the Kubo problem cost function that we had that Dr. Leah also used for the breast imaging as well. So slightly different than the one from the paper. So here I also kind of tried to, you know, like with this graph to kind of like to construct graphs with the different distance metrics to see, you know, like what could be potentially the best. And it looked like the Gaussian is the bimodal, and then it looked like it would be the best for this like a mean cut and like finding the global minima and separating these two classes. The rest of them had like more uniform distribution. So I continued with the Gaussian. And here, like for the method that I use for solving, I use simulated annealing and tableau search. I still did not get to run the quantum annealing. I'm still waiting for the API token. But with the simulated annealing and Gaussian distance with the sigma 0.2, the one that is recommended, I also use the quantum inspired image in order to, you know, increase the contrast and see, you know, like if that is going to help. And I'm here comparing the one that is, you know, filtered using this quantum inspired algorithm and the original image. And these are the results. So, I mean, prediction is the result. And this is, again, just like true mask and input image, just to kind of get a sense of, you know, how well the segmentation was performed. So here, if I'm just like, you know, for this particular setup, it looks like this quantum inspired image got like better prediction. So we can see like clearly these like white parts, which these are parts that were inundated. And then here, it did not do the best job, but in predicting the segmentation, but definitely if I would have like better resolution, I would expect better results. Again, compared to the original image, this looked better. I also tried with Euclidean distance, just like to see if there is going to be some change. To be honest, I mean, this original image, it did kind of pick up on something, but it's not really the best. The quantum inspired did not really look proper. And I went back to the Gaussian distance, tried with a bit more sensitivity with sigma 0.1. Again, I did not see any improvement compared to the first one. And here also run the simulated link with sigma 0.3. And it looked like the original image without doing any kind of quantum inspired filtering, also kind of, you know, generated somewhat decent segmentation results. I run also tableau search, and basically on both of them, you know, picking up these two best cases from you know, simulated annealing, I did not really get anything meaningful. So the conclusion is that, you know, with these results based on the Pakistan flood from the 2022, you know, like this simulated annealing with Gaussian similarity provided the most effective segmentation. So basically, these two different configuration, you know, yielded the most promising results. So there is like some reasons why, you know, like the quantum inspired processing, you know, like helped to enhance the contrast and reduce the noise, and, you know, get better like segmentation boundaries. And also the original image without processing with larger sigma provided, like a tolerance to intensity variation as well. There are a lot of things that need to be improved, like to scale to larger images. Hopefully that would also, improve as well, like, some resolution. What needs to be done for the change detection is actually comparing before and after images. So instead of like just using one image that I used here, that we need to kind of do the difference between before and after, and get this like contrast as well, and then try to see, if the segmentation would work better. Test on the real D-Wave hardware as well. So using the quantum annealing, and also see how to apply to different detection scenarios. What is also missing here is getting the performance metrics and comparing them consistently in order to see like if I'm getting in a good direction or not. So with that, I will thank you.